Hello students, so welcome to the lecture 3 of the Basic Electronics Engineering lecture series. So today in this video we'll be discussing the first topic, that is the resistance of diode. So the resistance of diode can be discussed in two forms, that is DC resistance and the AC resistance. So as you guys know, the main difference between the DC and the AC voltage is that the AC voltage is sinusoidal in nature with a frequency, and the DC voltage is linear in nature. This is sinusoidal in nature with a particular frequency in which it oscillates from a higher peak value and a lower peak value. And this range is called the amplitude, and the number of oscillations in 1 second is called its frequency. But in case of DC, it has a particular constant voltage moving through in the entire circuit. So now coming back to the topic, that is the AC and DC resistances. First, discussing about the DC resistances, we could say DC resistances are also called the static resistance, because this resistance does not vary with time. As we know, the DC current is a constant current, so as the current or as the voltage does not vary with time, same goes with the resistance. Following the so-called Ohm's law, that's V equals to IR. If V and I are constant, then R has to be constant, because V is proportional to I and V is also proportional to R. So now, analyzing the DC resistance of a diode, it is defined as the a semiconductor diode when used in a circuit which is powered by a DC source producing a certain resistance by the diode is called the static or DC resistance of a diode. So now let us look at the DC voltage current characteristic of a diode. So now looking at the current and voltage axis, we have this is the curve, and now this curve represents the DC characteristics of a diode. So in operation of a diode, at a point, it is called the bias region. The bias current starts. The bias region is activated. It's called the Q point. So from Q point, if two perpendiculars are drawn to either of the x and the y axis, the range of voltage from 0 to this point, the perpendicular dropped at this point, from this point, is called the VDC, or the DC voltage across the diode, and the current range from 0 to this point at which the perpendicular from the Q point is dropped is called the IDC, or the DC current through the diode. Now the resistance RDC is given by VDC divided by IDC. So note down this formula. So we have the definition, we have the formula, and we have the explanation of DC resistance of diode. Now moving on to the AC resistance. Now analyzing the DC resistance of a diode. DC resistance of a diode is also called dynamic resistance, because this changes with time, because the AC resistance is nothing but a sinusoidal wave which changes with time. This, when given to a diode, this diode produces a resistance which varies with time, and this is given by Shockley's diode equation, or the so-called diode equation, that is ID equals to Is whole into exponential of Vd by n Vt minus 1, where ID is the diode current, Is is the saturation current. Saturation current is the current which when given to a diode, the operation of the diode is fulfilled or stopped after that point. Normally saturation word can be explained as a glass of water. If a glass is filled with water, no more water could sustain in that glass. So we could say the water is fully saturated. In the same way, when adequate amount of current is given to the diode and the diode could not withhold the more amount of current and produce its characteristics, at that point the last quantum of current given to the diode is called the saturation current. Now Vd is the diode voltage, the voltage across the diode, the potential difference across the diode, and Vt is the thermal voltage, the voltage required to produce the heat from the diode. As you guys know, when a voltage is applied to a diode, the 0.7 volt, the loss in the voltage is converted into heat or the thermal energy, and N is the emission coefficient. Emission coefficient defines the emission at which the heat, or in case of LED, the so-called light emitting diode, it emits light and normal diode emits heat. This heat and light, when produced from a diode, producing a voltage drop of 0.7 volts, the coefficient of is the ratio which defines the recombination of the holes with the electrons. Now, when this AC voltage is given to a diode, a dynamic change in properties is seen in a diode, which can be explained from the VI characteristics, that is the AC VI characteristics. Let us observe that. Here we could see that to observe this, we have a change in voltage across and the change in current. To observe this, we have a changing Q point. So to analyze that changing Q point or the dynamic Q point, we should have a change in current versus a change in voltage, which is given by del IAC and del VAC, as this Q point constantly changes in this range. So in AC resistance of diode, the voltage, the change in voltage, the VAC, and the change in current, IAC, corresponds to the resistance of the AC resistance of the diode, that is RAC, which is dynamic in nature. So therefore we add the del symbol, which implies the range of resistance at which the Q point varies, and it's equals to V del VAC divided by del IAC. So here's the formula. There's the explanation and definition of the AC resistance of diode. So let's move on to the next topic, that is applications of diode, or the applications of Pn junction. So Moving on to the application of Pn junction or application of diode. So in application of diode we have, first one is LED, that is the light emitting diode. Second, this elaborates the property of the diode by virtue of which it emits light when electrons recombines with the holes in a semiconductor. Now in second we have clippers, then dampers and rectifiers. So clippers are the circuit which makes the now moving on to LED. So what is a LED? LED is a light emitting diode. Normally in a PN junction or a diode, the P half of the semiconductor comprises of holes and the N type comprises of the electrons. Now under forward bias condition, the electrons from the N type move on to the P type. Then in case of a LED, these electrons recombines with these holes. So while this recombination process, it emits light. Now this emission of light is only possible if and only if possible if the band gap in the P type and N type semiconductor, the band gap is of a proper cut. Now the emission of this light is possible if and only if the energy gap between the valence band and the covalent band of the semiconductor used in this PN junction is of the adequate manner, the semiconductor used in this PN junction is of the adequate material, which says that if by virtue of which the emission of light depends on the energy gap. That means this LED can produce all the range of visible lights as well as the infrared lights and the ultraviolet lights. So the wavelength of light will decide whether it's ultraviolet, whether it's big gear, the violet, indigo, orange, red, all these colors, or it's infrared. So this wavelength depends on the energy gap of the PN junction. So you guys know your mobile phone or an LED screen. If you look at these screen minutely in a magnifying glass, you'll observe that each and every comprises of 4 boxes. Each box having a specific color. Those are the primary colors. Though the primary colors are the red, the blue and the yellow, but in this case we have the primary colors, the R, B and G, red, blue and green. So moving on to the LED, so this characteristic of light depends on the energy gap. Now moving on to clippers and clampers. Clippers is the process of elimination of certain wave from our input wave. Suppose we have this input wave, a sinusoidal wave, and in the output wave is if in the output wave the upper half is missing in each of the layers, in each oscillation, then we could say then we could say the input is given to a clipper circuit which eliminates a certain area or a certain range of the signal. Now discussing about the clamper. A clamper is a circuit which, when given our input, it shifts the entire signal either up or down, or it could invert it. These all things a clamper can do. Clamper can shift up, shift down, or invert a signal or a section in a signal. Now, what is a rectifier? A rectifier is a circuit which converts a AC signal to a pulsating DC signal. For example, we have a AC signal in this manner. It converts this signal to a variable DC signal. It will have no negative halves, or it is the output of a full wave rectifier. In half wave rectifier, the output is in this manner. Only a half wave of the input signal is being rectified. So I told you all the details of the LED. Now, if you find this video informative, please hit the like button. If you have any doubt in any topic, write us in the comment section and subscribe the channel to stay connected with us. Thank you.